Hello my dear students, today we are in lecture number 29 of second chapter unit electrostatics. My dear students, today in this lecture we will study about the common potential and then infinite ladder problem and few concepts of loss of energy. While studying the common potential, we will study the loss of energy. But we will start today lecture with simple numericals. Okay, we will learn few numericals. I am B.S. Pandey, the student. Uh, if you follow my lectures, I left with last lecture few examples. Okay, other one numerical question I'm giving you to solve. This is also a simple question. You have to find here for this question equivalent capacitance between the terminal X and Y. Okay, my dear student, this is the terminal X and Y. The capacitors are connected here in this way. The aim of this question only to enable you how to see the series and parallel capacitor or the network. Here it is 2C, 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 and this is suppose C. Okay, my dear student, you have to find the equivalent capacitance of this network first. Now, this is 2C. Okay, between this two terminal X and Y, my dear student, you can see the simplest combination, as I told you to see the simplest thing first. Okay, so you can see these two are in series. Here these two are in series, and this series and series become parallel with each other. So of this circuit, if these two are in series, 2C and 2C will be C. So the one capacitor here between these two terminal, we are having a capacitor C, this one between X and Y. Now this two capacitor become one, and it is how much? It is C. Now this 2C and 2C become again another capacitor which gives you the C, the two terminal X and Y you can see over here. Now these three are in parallel, so the answer will be the C plus C plus C. So the C equivalent, it is 3C. Okay, 3C. Now next question, my dear student. In this particular question, you have to again find the equivalent capacitance in this network. This is another simple network. This is the terminal X and this is the terminal Y. You have to find the equivalent capacitance. I am giving you the value of capacitor 2C, 2C, here C, C, 2C, and then it is 3C. Okay, you have to find the capacitance. Now equivalent capacitance, student, this is your classwork. If you can solve, pause your video and try to solve. Let me solve this question. Students, look at carefully. Student, these two are in parallel. Okay, these two capacitors are in parallel. If these two capacitors are in parallel, then the answer will be C plus C, and it is 2C. So the network looks like this one. this 2 will be one capacitor, and you can add at any place this one capacitor. This is C. Now this was 2C. This is 3C. Okay, this is 3C, and this is 2C and 2C, and this was the terminal. Okay, my student. Now this is C, and this was in parallel, I think, and this is 2C. This is 2C. 2C and 2C in series. This will be C. These two are in series. This will be also C. Okay. So the next diagram will be like this way. This is the 3C. This one. Now this is 2C and 2C series. That is C. And then we are having another capacitor. This could be the terminal Y. Another capacitor between this point and Y, this point and Y, it is 2C and 2C in series, it becomes C. Now this C and C, it is in parallel, and this 3C will be in series. So the next circuit will be like this one. The C and C, 2C, and this 3C. Now these two are in series, so the C equivalent you can write 3C times 2C by 5C, that is 3 plus 2, so it will be 6 by 5C. So this is the answer. And this way, student, one by one, that is the step by step, you can solve any equivalent network. Let me solve few more questions, my dear student, and then after I will give you some homework. Okay. Okay, my dear student, try to solve this question. This is your classwork. Two terminal, suppose X and Y. Again, all the values are C. Okay, all capacitors are identical. You have to find the equivalent capacitance between X and Y. This one question and the second question I'm giving you here. Okay, this one. This is the important question. X and Y. Again, all the capacitors are identical. Of value C microfarad, you can say. Now, student, you have to find the equivalent capacitance in both the network. Okay. First, let me solve this question. 1. Suppose the point 1, 2, 3, 4. Okay, and this is the point O. Here, student, you can see this point X, which is 1, and 2, it is connected with a conductor. Okay, there is no component between 1 and 2. Now 2 and 3 also connected with the simple conductor. It has no any device. Now 4 and 3, that is 3 and 4, also connected with a conductor. And due to the simple conductor, point at the end of conductor will have the same potential. It means 1 and 2 will be at same potential, 2 and 3 will be at same potential. So there is no scope of flow of charge and current. If there is no flow of charge and current, then you can attach this point 1 and 2 with each other. And then the circuit will looks like this one. Look at carefully. Okay. The circuit will looks like, if you will go with the point 1, 2 and 3 at the same position, then this will be, look at here, I am cutting out these conductors, and putting 2 at the position of 3 and putting 1 at the position of 3, then it looks like this is the point O and this is the point 3, which is Y. In between O and 3 you are having a capacitor. Okay, now this point 2 has to go at point 3, but between this O and 2, which is going to at point 3, there is one capacitor, so connect a capacitor. Okay, now to point 2 has been gone at this point 3. Now 1 is to move at 3 also. This is O. 1 will move to 3 and there will be a capacitor between 1, this is 1, and O. So this is O and this become 1. Now 1 gone at the point, remember this 3, but this 4, look at here, between O and 4 there is conductor, so you can just skip this conductor and connect this point 4 with 3. 4, which is holds another end at O, so this is O and this is the point 4 which gone to the point, okay, 3. While this 4 is going at the point between 1 and 4, remember 1 was at this point, which is gone at point 3, okay, and 4, which was at here, this is also gone at, it means the 2.1 and 4 gone at 3 and this capacitor will goes off. 1 goes at point 3 and 3, 1 are the two terminal. It means there is no potential difference between 1 and 3, so the net potential, net capacitance will be how much? It is 0. Okay, directly I had answered that the equivalent capacitance will be 0, but you might be you become confused. That's why I explain this way. Here there was a conductor, okay, like this way, and these two terminals are connected, terminal X and Y are connected with a conductor. With no device, if it is connected with the conductor, then both point will have the same potential. If there is same potential, no flow of charge between these 2 points. If you will connect a battery, suppose if you connect a battery, what will happen? There will be no flow of charge, so equivalent capacitance has nothing to take. It will not play any role in any circuit. Now come to this question. Now student, you can see this conductor again, it is connected with these 2 points and the potential of these 2 points will be same. Now you can simplify the circuit like this way. This is the point. Let me write 1, 2, 3. This is 1 is X itself, 1 and 2, only 2 points we are taking. Okay, I hope you are getting. We're taking the X, 1, 2 and Y. So between 1 and 2 we are having a capacitor. This is the point 1 and 2. Now from 1 and 2 we are having a capacitor which is going at the point Y. There's a capacitor, this is the terminal Y, and this is this point 1 gone at point Y with a capacitor Y, okay, with a capacitor. Now this point 2 has no capacitor. It means X is to move, this was the X is to move, this is 1 between 1 and x there's a capacitor. So this is a capacitor, and x is to move at point 2, and this will be the new terminal. This x or this one is now x. Now the capacitor C and C. Try to find out the answer. You can see, my dear student, these two are in parallel. You can see this is the conductor 1 point, this is 1 point, these two are in parallel. So the next diagram will be like this one. These two are in parallel, so the C and C will be 2C. This is 1. Now this is the point 2, and this is 2C, and this point 2 is x itself. Okay, so we can write here the x. One capacitor, it was C, this is the y. Now one capacitor, and above it was one capacitor which is going at point, this one, it is C. Now student, if these two are the terminals, you can see these two are in parallel series. Okay, so if these two are in series, then the next diagram will be, if these two are in series, then equivalent of these two will be C times 2C by 3C. Okay, it means 2 by 3C, and the circuit looks like this is C, and this one is this capacitor, the X point over here terminal and Y terminal over here. Now these two are parallel, so the equivalent capacitance will be 2 by 3C plus C, that is 5 by 3C, and this is the answer, 5 by 3C. I hope you understand these two questions, which are very interesting. Now I am giving you another question that you have to solve by yourself. I'll give you some hint also in this question, but this is your homework. You have to find again equivalent capacitance. We are connecting a conductor over here and over here. Identical capacitors, terminal X and Y. You have to find the equivalent capacitance between this two terminal X and Y. You have to find the equivalent capacitance. Okay, my dear students. Now come to the next topic. Our next topic was common potential and infinite ladder problems. So after infinite ladder problem, we'll move to the common potential. Okay. Suppose, my dear student, you are having a circuit in this way. In which number of capacitors are connected. And this type of structure going to infinity, and these are the two terminal X and Y. Okay, between these two terminal you have to put a battery, but the question is to find the equivalent capacitance. Remember, if you will change the battery from 100 to 200 volt or 100 to 50 volt, capacitance, equivalent capacitance not going to be changed. Here the value of capacitance are given, capacitors are given identical. Suppose it is C. Okay, look at here carefully, my dear student, because the number of the question you will find, and after solving this question you will be able to solve the number of question if you'll understand properly. This is going to be infinity, remember, till infinity. Suppose, my dear student, if I'll hide this particular section, look at here carefully between X and Y. If I'll hide this particular section, the circuit remains same, since it is going to going to infinity. So by hiding two capacitor, there will be no great change. If you will hide two section, then this will be same as earlier. It means the equivalent capacitance of this one section will be the same as the equivalent capacitance of this whole circuit. I hope you understand. Suppose the capacitance of this dotted circle, this is C naught. Okay, this is C naught. Again, I'm explaining. If you will hide this particular section, it looks like same. Remember, while you are hiding, you cannot hide only this capacitor. If you will hide this capacitor, it will not as earlier. It will not looks like as earlier. You have to hide, and you have to hide the minimum capacitor so that you can see the same branch. Okay, the same branch. If you will hide this two capacitor, it looks like the same circuit. Look at here, this one and this one. Along this one, you have to see this capacitor arrangement. This capacitor means is it going to infinity. Remember, it is going to infinity. So by hiding this one, there is no great effect. And for this particular total arrangement, the equivalent capacitance will be how much? Again, C naught. And this one is also C naught, because in C naught, if you will add or subtract something, that will not affect much. Now, but due to this consideration, the circuit looks like this one. Look at here, the circuit will be like this one. This is the capacitor here, X and Y. But from here, you can see from here and from here, we got all this value as C naught. So connect a capacitor, this one as C naught, and this is C and this is C. And what is the value of this arrangement now? Yes, the equivalent capacitance of this arrangement is also, it is C naught. Now you can see this is 2 in parallel. So what will be the answer? The C naught plus C. C naught plus C. And after this one, this is in series. So into C by C naught plus C and plus C, and which is equivalent to how much? C naught. Now C naught is equals to C naught plus C times C divided by C naught plus 2C. Now this was the concept actually. It is solved now. You will find there will be a quadratic equation while solving this one. You can see the C naught square plus 2C C naught is equals to C naught C plus C square. What is variable? Variable is C naught that we have to find, and it is quadratic equation. So there will be two roots. The negative value, since capacitance will be not negative, so negative value we will leave and we will take the positive one. That is the answer. So that will be the equivalent capacitance. I am giving you, my dear students, another question that is for your homework. Kindly note down. I am rubbing this one. Okay, so this is your homework, my dear student. You have to find the equivalent capacitance of this network. All the capacitors are identical and it is going to infinity. Okay, this one. All the capacitors are identical of value C. I'm not writing, it will be osmolar. So you have to find the equivalent capacitance of this network. You will leave in comment section. I'll give you the answer. Otherwise, in next lecture I'll solve this question. So this was the infinite ladder problem. Now, as I told you, today we will study the common potential concepts. So let me start common potential problem. Common potential problems. Okay, my dear students, let us suppose you are having a capacitor C1. It is charged by a battery of V1. Okay, another capacitor you are having C2. It is charged by V2. Then what will be the total charge? Here Q1 will be C1 V1 and Q2 will be C2 V2. Okay, it is clear to everyone? Yes. Here the C1 V1 and Q2 C2 V2. The total charge of network will be initially, okay, what will be? It is C1 V1 plus C2 V2. Okay, one by one you can find out the energy also. Energy of first capacitor will be how much? Half C1 V1 square, and of second capacitor it will be half C2 V2 square. And total energy also you can find. The total energy U total initially will be U1 plus U2. Now, my dear student, if these two capacitors are connected together, then what will be the potential? Okay, it has been charged, and battery is removed. How much charge has been accumulated? It is Q1 and Q2 over this capacitor. Now these two capacitors we have to connect together. If two capacitors will connect together, that will be in parallel. Remember, always only two capacitors are connected, they must be in parallel. This is C1 and C2. Now you have to find the common potential between these 2 points A and B. Okay, if you are finding the common potential, what is conserved? Here the total system having the energy, the charge, it is Q1, and this particular total circuit should be the same energy charge, because charge is conserved. Energy might be changed, because when we charge a capacitor, when we discharge a capacitor or charge a capacitor, energy loss, okay, loss in energy takes place. So here the common potential, but the total charge Q total, which is final, it must be equals to the initial charge, and final charge will be how much? So the final charge, it is Q is equals to C total. Since both are in parallel, so the C total will be C1 plus C2, and V total, suppose the common potential of this entire circuit is VC. C stands for common, which is equals to how much? It is the initial energy. It means C1 plus C2, it is, or the common potential VC can be written as Q initial. It was, you can see over here, it is C1 V1 plus C2 V2 divided by C1 plus C2. They're very simple, my dear student. Okay, now you can write the energy of individual capacitor and the total circuit also. Here the energy after connection, you can write U1 will be how much? Half C1 and V1. What is the V? Here the potential will be common for both, and which is VC. We have calculated already, so it is VC square, and U2 it will be half C2 VC square. And what will be the total energy? So the total energy should be like this one, half CV square, and C will be C1 plus C2. Okay, and VC square, even after adding this both, you can find out. Now, if this is the concept of common potential, student, could you find the loss in energy? Yes, you can find the loss in energy. How? So loss in energy, this is also very important, my dear student. Loss in energy. Okay, so loss in energy is nothing but the change in potential energy initially. Okay, initially the energy with this particular capacitor was how much? It is half C1 V1 square. Now finally this particular capacitor having the energy how much? It is half C1 Vc square, that is the half C1 plus C2 and okay V common square for this particular, sorry, this one. Now the change in energy of first capacitor you can find, it is delta U for first capacitor, it is U1 final minus U1 initial. In this way you can find out the loss in energy of the second capacitor and you can find out the loss in energy of entire network. All the equations have been written over here. Now students, if I'm giving you a question, okay, then you can solve. I don't think that would be very tough for you. This is your home assignment, homework. Remember this particular question, it is given in your NCERT also. Suppose the first capacitor, it is C1 charged by potential V and the second capacitor C2 is uncharged. Okay, uncharged. It means it has charge how much? 0. Now the question, if we connect a capacitor C1 with a battery to charge by V and disconnect the battery, now these two capacitors join together. Of course, the both will be in parallel. Now you have to find the common potential. Find common potential. Okay, this is the question. You have to find the common potential and also you have to find the loss in energy of capacitor 1 and 2 and the total loss of energy of entire circuit. Again, I'm explaining this question. First, this capacitor is charged by battery V, then battery disconnected, and this C2 which is uncharged connected with this capacitor C1. You have to find the common potential and loss in different energies, that is on the different capacitor. Okay student, so this was the concept of common potential and loss in energy. In next class students, we will study Kirchhoff's law, that is the very important section. Okay my dear students, thank you very much.